Good afternoon, ladies and gentlemen. I hope this presentation finds you well. Today, we are going to present you a conceptual design for a blue hydrogen ATR system. The general objective of the project is develop a conceptual engineering design for a 350 million standard cube feet per day blue hydrogen ATR system in La Guajira, Colombia, considering political, social, and environmental factors. The design will prioritize commercially mature technologies for process optimization and feasibility. Regarding the specific objectives, the first one, analyze the availability of natural gas and the raw materials in La Guajira, considering political, social, and environmental constraints and limitations. The second one, design an ATR-based blue hydrogen plant with carbon capture, ensuring compliance with standards and economic feasibility. And ultimately, evaluate process feasibility using CapEx, OpEx, and put the economic potential 2 and economic potential 3.
Design problem. Colombia faces the challenge of reducing greenhouse gas emissions. In this context, blue hydrogen is a key solution. Reasons overview. Where the steam methane reformer is the most used method for hydrogen production, it begins with methane reacting with steam over an intercatalyst. This reaction is endothermic. Then it goes to a water gas chip reaction, where CO reacts with steam to produce additional H2 and CO2. This process occurs in two stages: high temperature reactor and a low temperature reactor. Then hydrogen is purified using pressure swing absorption, which removes impurities. Meanwhile, the process optimizes energy use by recycling of gases. Well, we chose La Guajira as a strategic location because it supplies 66% of the country's gas and it has high methane contents and also there exists infrastructure for transportation. Well, some environmental and social limitations are La Guajira is highly vulnerable to climate phenomena and La Guajira faces water scarcity. The department's water sources are under special protection. Well, some constraints are that it requires consultation with indigenous because 73% of Guajira's territory belongs to an indigenous community. Well, regulation currently exists several decrees, laws that promotes hydrogen utilization, incentives hydrogen projects, regulate carbon dioxide emissions, and offer tax reductions. Well, some technical factors are for transportations, primary gas ensures a stable supply of natural gas, while air liquid provides on-site oxygen, reducing logistic costs from the Evangelia River, and ensuring availability. About risk analysis could be water scarcity, oxygen security, and gas supply dependency. Well, about the matrix, the implementation of autothermal reforming enhances energy efficiency and hydrogen production compared to other methods. Key opportunities include strong industry demands in sectors like fertilizers, mining, and steel, along with tax incentives for carbon captures and renewable technologies. However, high capital and operational costs, as well as limited short and medium-term hydrogen demand, pose significant challenges. Additionally, the future dominance of green hydrogen and international competition could limit market expansions.
All right, I'm Nathaniel. I'm working on solution alternatives. The first alternative we chose was a GHR and ATR reactor alternative. Essentially, instead of using an ATR reactor, we are essentially feeding the natural gas and steam into a heat exchanger with tubes filled with catalyst that are heated from the output of the ATR reactor. This saves a lot of energy, and it both partially reforms 30% of the methane and causes complete reformation of methane in the autothermal reactor due to reaching temperatures of 1500 degrees Celsius. It's very good, which is why we chose this specific alternative for ATR. So for carbon capture alternatives, we have a few different options. We have amine absorption, cryogenic capture, and rectisol units. We ultimately chose alternative 2, the cryogenic capture, as it's TRL9 and is a simpler process that produces up to 98 to 99.99% carbon capture. And it also creates liquid CO2, which is ideal for transport, storage, and other petroleum use. It has some downsides, but I think the benefits outweigh the downsides, as do the rest of the group. This is the block flow diagrams for all of them. As you can see, it is very similar to one another. The only difference really between the amine absorption rectisol and the cryogenic is that the carbon capture for the cryogenic is after, as you want a high concentration of carbon dioxide in the system. Um, the process diagram is very big and complex. Essentially, we have an electric heater heating our gas initially to desulfurinate it, and then we have it going to two separate pre-reformer and ATR units. These all go into a water gas shift before going to an absorber and a pressure swing absorber before heading up into this furnace to heat up all the water in the system. And then that said flue gas flows down into the carbon capture um, to get separate into carbon dioxide, liquid, and in the remaining gas. And this right here is essentially all of our equipment. Um, it is a lot of equipment, and it is not the final measure, but this is essentially it for my section. So, thank you.
Well, in the CapEx and OpEx calculations, the pressure swing absorption tower had higher CapEx than the water separation unit, because I would say it is significantly higher, larger in diameter and length. Well, on the other hand, the compressors had much higher CapEx and OpEx than the other equipment, mainly due to their high energy use and strong design needed for high pressures and flow rates. Nevertheless, heat exchangers also had high operational costs because of the large heat transfer demands in the process. And a preliminary estimate of economic potential 2 and economic potential 3 was made using the calculated CapEx and OpEx, taking into account raw material costs and revenue from hydrogen and carbon dioxide sales.
Question 1. Because our capstone design project is a strategic solution for Colombia's energy transition. Environmentally, it reduces carbon dioxide emissions using autothermal reforming with carbon capture, supporting the country's climate goal. Socially, it creates jobs opportunities and La Guajira, fostering local development. Economically, it capitalizes on Colombia's vast natural gas reserves, lowering reliance on imports, benefiting from tax incentives that improve its financial feasibility. This project positions Colombia, making it a sustainable and profitable investment.
As for question 2, what aspects or assumptions would you recommend reviewing in your capstone design work? We would like to first review the ATR reactor versus the GHR ATR reactor, as we believe that we have deviated from the project statement, and as such, we should do a review between the two. And why we should do it. Another aspect of review should be the comparison between the assumptions given by the project statement and the assumptions used in the final report, as we have utilized some assumptions while not utilizing other assumptions.
Well, in conclusion, the conceptual design for the ATR system for blue hydrogen in La Guajira is technically viable, integrating carbon dioxide capture to comply with environmental regulations. However, it faces economic challenges due to high investment and operating costs, as well as logistical and social limitations in the region. Despite these challenges, tax incentives and the growing demand for hydrogen present opportunities for its development, provided that optimizations and sustainability strategies are implemented. Well, thank you so much for your attention.